9.4, we are looking at operations of functions. So the first four on here we've actually done before. It's just a different formatting that you're seeing them written in, a different notation. And then the bottom are going to be the new ones on there, which I'm looking at it right now and realizing that I skipped number 5. But anyways, so this, if you look at the first example, for all the examples we're going to use these two for F and G, just to make it simple. So the first one, this is just saying function f plus function g in terms of x. So this really, you can kind of ignore that. That's just saying, hey, x is the variable that we're using here. Lots of times kids want to do the work and then multiply another x through. That's not what that means. That x on the end just means, hey, we're using x as our variable. Or if it was y, it would be a y there, or whatever letter you want. So this is just saying let's take f and add it on to g. So I have x squared minus x minus 6 plus x minus 3. It's just combining like terms. So I have x squared, those would cancel, minus 9. So that is f plus g of x, just adding them. Okay, second one, example 2 is subtraction, so very similar. F minus g is going to look like this. So I have x squared, I have negative x minus x is negative 2x. Negative 6 minus negative 3, negative 6 plus 3. So that would be negative 3. Okay. Example 3, we are multiplying them. So you can do the double distributing, or I like to do the box method. So I'm going to set that up. If you want to do the double distributing, you can. It's up to you. So we're going to multiply into each of the boxes here. And then combine like terms. There we go. And then dividing. So dividing, this is just saying take function f, divide it by function g. So I have x squared minus x minus 6 over x minus 3. Remember that you have to factor this in order to divide it, as long as we have a common factor. If we don't, you'd have to do synthetic division. So this would be negative 3 and plus 2. And those would cancel. Oops, sorry, run out of room there. So your answer is x plus 2, and we should still be in the habit of saying what our undefined term is. So that's our answer with dividing. All right, so composition of functions, this is most likely going to be new. So these are two different ways to say the same thing. You see a little open circle like this. This means composition of functions, and this means the same thing. So the way you read this is f of g of x. Both of those would read that way. Okay, so this first example is saying f of g of, or sorry, g of f of 2 is how you say that. So what that means is we're going to work on these from the inside out. So I'm going to start with a 2, and I'm going to take the 2 and I'm going to substitute it in for x in the f. I'm going to get an answer from that, and then whatever answer I get from that, I'm going to plug into g. So what does that look like? So let's go back and write down what f was. So f was x squared minus x minus 6. So I'm going to replace a 2 into the x's on my f function. So first I'm doing f of 2. So that's going to become 2 squared minus 2 minus 6. So that's what? 4 minus 2 is 2. 2 minus 6, negative 4. So f of 2 is negative 4. Now I'm going to take that negative 4 and I'm going to plug that into g. So now I'm doing g of negative 4. G was just x minus 3, so this is negative 4 minus 3. So that equals negative 7. So g of f of 2 equals negative 7. This actually has an extra parenthesis on here that it shouldn't have, sorry. Okay, so this is the one format. This is the other format of how you're going to see it. And again, you work kind of backwards from this. So I'm starting with the -4, and I'm going to substitute that into g first. So g of -4 means -4 minus 3. So that's -7. And then I'm going to take that answer and substitute it into the f. So now I'm doing f of -7. So this gives us what? So f of g of -4 is 50. All right, and two more. So this is when you have a number that you are substituting in on example 6 and 7 here. You're going to get a number answer. These, example 8 and 9, we are going to get expressions as our answers here. So what this one means, again, kind of working from the inside out, this is saying I'm going to take the function g and I'm going to substitute the whole function in for the x's in the f function. So g was x minus 3. So this is going to become x minus 3 squared minus x minus 3 minus 6. So that is just substituting in an x minus 3 for all the x's in the f function. Now we got to simplify that. So remember that this gets FOILed. You don't distribute that. So this is going to become x squared minus 6x plus 9. That's going to distribute out there if I'm simplifying. And then combine like terms. I think that's right. So this is what you would get from f, I should write that in the front, f of g of x. Sorry, running out of space here, that looks sloppy. Okay, and then the last example is doing the same thing, we're just doing it the other way around. So now, again, kind of working backwards, I'm taking the function f and I'm plugging it in for the x's in the g function. So since g was just x minus 3, I end up with x squared minus x minus 6 minus 3. Because remember, g was just x minus 3. All of this is replacing that x. So now simplify. This is g of f of x. All right, so you've got the last two to do. The first one is just plug the 3 in, so you should get a number answer here, and you should get an expression answer there. All right, and lastly, for your joke of the day, why did the frog take the bus to work? Because his car got towed. All right, well, have a lovely rest of your day, and I will see you later.